Presenting Team Amatec Sulfur. Team members are Armias, Justin, Baron, Reagan, and Joseph. Faculty mentor is Dr. Thomas Koch. Our industry supporter is Brandon Forbes. Our project sponsor is Amatec CSI. The focus of our project was the prediction of liquid levels in the piping systems used to remove sulfur from petroleum products in a refinery setting. These piping systems are known as rundown lines. We designed and built a test apparatus that allows us to measure and observe flow behavior across a range of slopes, pipe sizes, and flow rates under similar conditions to those in the rundown lines. The apparatus will provide data and validation for our previously developed analytical method for liquid level prediction inside the rundown line. Liquid level measurements were taken at 10 different points across each rundown line. The measurement data was used to identify critical points in the system where flow levels were more sensitive to flow rate and slope conditions. Analysis is being conducted to determine the relationship between the predicted liquid level for simple sections of pipe given by our analytical method and the measured liquid level at those critical points. The project prototype was designed with 8-foot sections of straight pipe to emulate actual rundown lines and to allow for uniform flow to develop between each junction. Pipe stands were used to support the rundown lines, and that allowed for multiple pipe sizes and variable slopes with the same pipe stands. The test apparatus simulates real-life conditions through a condenser and sump inlet. The real-life condenser can be seen pictured here, so we modeled our condenser basin to simulate the bottom of this condenser. Flow observations were made at critical points. Here the effect of slope can be seen on the flow behavior as it approaches a junction. Flow observations were also made on a larger scale with a higher flow rate, allowing for significant backflow to be compared to situations where no backflow is observable. We were also able to observe the flow inside of the junction and observe the difference between the percentage of air gap that was present in a lower flow rate and at a higher flow rate. Here's an observation of the backflow as you're approaching a horizontal 90-degree junction. In this area we observed at a significant level of sensitivity to flow rate and slope. Thank you for taking the time to watch our presentation.